Welcome to our short introductory video on LV Electrical Reticulation in compliance with the SAN standards. The successive phases in the life of an electrical network comprises of 4 typical phases from its design on through to upgrades. The characteristics of the MV network will determine which switchgear is used in the MV or MV-LV substation. Familiarity with these characteristics is essential when defining and implementing connections. Now let's look at MV radial or fishbone networks, single-line service. The substation is supplied by a tee-off from the MV radial network, overhead or cable, also known as a spur network. The substation usually consists of an incoming panel, and overall protection is provided by a load break switch as well as fuses with earthing switches. In some countries, the substation comprises of a pole-mounted transformer without a load break switch or fuses installed on the pole. This type of distribution is very common in rural areas. Protection and switching devices are located remotely from the transformer. Now let's look at ring main service, double supply. The power supply for the substation is connected in series to the power line of the medium voltage distribution network to form a loop. This allows the line current to pass through a bus bar, making it possible for loads to have 2 different power supplies. They are used for the underground MV distribution networks found in urban areas. In the event of a breakdown on one branch, low voltage customers can be supplied through another branch from another transformer with very little interruption of the service. The substation has 3 medium voltage modular units or an integrated ring main unit supporting the following functions. Incoming panels, each with a load break switch. These are part of the loop and are connected to a bus bar. Transformer feeder connected to the bus bar. General protection is provided by load break switches, a combined load break isolating switch, or a circuit breaker. What is the difference between electrical reticulation networks in urban and rural areas? Population densities are lower in rural areas than in urban areas. There are larger plot sizes in rural areas than in urban townships. Larger distances are involved in rural areas. Where roads do exist, there is generally a large distance between the road and the dwelling itself. The lack of formal township planning or layout in rural areas, more specifically, the roads are not straight. These practical difficulties may be summarized as follows. Longer cables. The lower population density in a rural area and larger plot sizes requires that longer low-voltage house service connection cables are needed to supply each consumer. A technical implication of this is that long cables result in larger volt drops. Therefore, larger cross-sectional areas of conductors must be used than would normally be required from purely current-carrying capacity considerations. An alternative to the use of long runs of LV house service connection is to supply each small group of consumers with its own step-down transformer. The implications of this alternative are that smaller transformers than normal are used in urban projects. The increased length and complexity of the HV cable network increases the cost. To reduce the cost of the HV cable network, a lower and hence cheaper distribution voltage needs to be considered. For long distances, generally the highest practical voltage is the most economical. That wraps up our short introduction of MV and LV electrical reticulation. Remember to subscribe, like and share. Thanks for watching. Stay safe, stay informed, and see you in the next video.